Assalamu alaikum, hello everyone. My name is Abdulrazak Zakiya, and today I'll be presenting our paper Al-Jawaab at Qur'an QA 2023 shared task, which is about exploring embeddings and GPT models for passage retrieval and reading comprehensive. The presentation by me, Abdulrazak Zakiya, and Dr. Fadi Amrosh. This is a brief overview about Dr. Fadi and me. Then I'll be moving to an overview of the shared tasks, which is composed of two tasks. Task A, passage retrieval. We have a question in modern standard Arabic, and for that question, we'd like to retrieve up to 10 passages out of the Quranic passage that we have. And the rank matters in this task. Also, we have some cases that we might have no answer at all, so we have to specify such cases. In task B, which is a reading comprehension task, we have a question and also an MCA, and we have a corresponding passage. And from that passage, we'd like to extract the parts that might have an answer to that question. And again, up to 10 parts. And again, in some cases, we might have no answer. To the right, we can see some, let's say, samples of those tasks output. For task A, data, it's being composed from different sources: the Quranic passage collection, QPC, the ayatic questions dataset, and the query retrieval relevance, the query relevance judgment Q rails. For task B, it's composed about 1,400 triplets, and those triplets are question, the passage, and the corresponding answers. In both tasks or datasets, we have about 15% no answer records. In task A, the split was 70% for training, 20% for testing, and 10% for development. And in task B, it was 64% training, 26% for testing, and 10% for development. What we have done for task A is the following. We wanted to test the embedding of OpenAI, which is text embedding ADA 002. This embedding is using about 1,536 dimension embedding vectors to represent the text. And then we get or measure the cosine distance between the embeddings of the question and all the embeddings of all the passages that we have. Then we sort those, let's say, passages according to their distances. Of course, the lower distances will be at the top, and then according to some threshold, we select the top 10 that are bigger than the threshold if it is the similarity score. If there is nothing bigger than the threshold, then we indicate the no answer case. For task B, we have used GPT, which is a generative pre-trained transformers, and we tried both GPT-3 and GPT-4. The difference is in the training data and the number of parameters, which is much higher in GPT. In this model, we have different scenarios to follow. For example, we can send directly the question to GPT and get the answer, but we get an answer that's from the trained data that GPT has. So the answer could be something wrong, and we don't like that, especially in Quran answering. So what we can do is we have a prompt, we send them the question, and then we send the passage, and in order to get an answer that will give us a slightly better result. So we like to ask GPT within the prompt to only give an answer from that passage. But again, GPT still can get out of the text. So there is a parameter which is called temperature, and we can set it to 0 to get more definite answers, but not full definite. Again, we use the search scenario. We can see to the left our hand-crafted prompt, and to the right we can see some answers for GPT 3.5 and 4. This is the result. In task A, we achieved lower than the base model, but for task B, we achieved higher than the base model, and the increase in task B as a performance is about 67%. Finally, the conclusions the limitation are the cost of using those GPT models, especially GPT-4, and the explainability of the results. Thanks for listening.